Okay, so in the last video we discussed method 1 and we proved why 255 is the biggest number that can be represented in an 8-bit binary. In this video we are going to discuss the method 2 of converting from denary to binary. Let's start. Let's take an example, which let's say again is 28, because we know its number that we converted in the last video is 11100. Just a second. Double zero and 3 zeros before it. There's the final answer which we must get for this number. In order to prove this number, we must get this binary number from method 2. So method 2 is the reverse process of converting from binary to denary. So for this one, we first need to write the powers of 2. 2 power 0, 2 power 1, 2 power 2, 3, 4, 5, 6, 7. These are the powers of 2. Now let's write down the corresponding numbers with those powers, which will be 1, 2, 4, 8, 16, 32, 64 and 128. Now the way we are going to convert this number into this one is like this. We are going to compare this number with every number starting from the left. So it works on like this. If the very first number is 128, if you compare this number with 28, of course this number is bigger than 128, which means that in final answer this 128 cannot be added. So we will simply put 0 here, and when we compare this number with the next one, which is 64, so if you compare this number with this one, it is of course greater than 28, like 64 is greater than 28. So this number cannot be 1, because we do not need to add it in the final answer, so it becomes 0. And again, when we compare this number with this one, it is 32 and it is 28, which means that 32 is greater than 28, and this number will not be added again. And when we move on to the next number, which is 16, it is less than 28, which means 16 is less than 28. So in the final answer we need to add this number. So it goes on like 1, and it means that when we will convert this number back to denary, we will add this number to get our final result 28, which means that that we first need to subtract 16 from 28, which is which is 12. So it means that 12 is left to be added with number 16. We need to consider 12 right now. So if we move on to the next one, now we need to consider this 12, not 28, or maybe 16 if you are concerned. So if we compare this 12 with this 8, it becomes like 8 is less than 12. So of course we need to add this one number also to get our final result 28. And if we subtract this number again, that 12 minus 8, let me do it from the beginning. In beginning we did 28 minus 16, which becomes 12. Now we will do 12 minus 8, it becomes 4. It means now 4 is left. The 4 is left to be added. And of course, as we move with the next one, now let me tell you this, that it's not necessary that this number cannot be equal to this number. What is necessary, that this number should be greater than or equal to the number you are comparing. Only then and there you can add 1. Now since we have added this 4, and if it's subtracted, it becomes 0, which means these three numbers, we'll get it the altogether answer as 28. So the last two number will be 0. And the reason behind why I didn't start from this side, I will tell you in a second. Let's try to convert this number back in. So of course, if we try to convert this number back in, it's 16, which is corresponding to 1, it's 8, which is corresponding to 1, and 4, which is corresponding to 1. And if we add them all together, it becomes as you know, 28. Now let's consider that why this number, that why we didn't start from right to left while converting into binary. Let's write down the numbers directly instead of writing down the powers, because we don't have much space here. 4, 8, 16, 32, 64, and 128. So if we start from here, so if we compare this number with this one, 28, if we compare 28 with 1, of course 1 is less than 28, which means that this number need to be added in the final answer. So we will place 1 here, and as we explained before, we need to subtract that number from the initial number that we are about to convert, because after that we will get to know that how much more we need to add to get our final answer as 28. So in this case it becomes 27. And then if you move on to the next one, it is 2, which is again less than 27. So it means we will put 1 here also. And if you subtract it from here, it becomes 25. It becomes 25. And 4 is again less than 25. So it means we will put 1 here again. And if we subtract 25 by 4, it becomes 21. Now let's move on to the next one. Now if we see this 8 is again less than 21, so we will put 1 here, and we will subtract 21 by 8, which eventually becomes 13. As we move on to the next one, there comes in a conflict. When we compare this number with this number is of course greater than 16, which means that we cannot write 1 right up here. That means that if we move on to the next one, the number will get bigger and bigger and bigger, and there will be no way that we can now write this number 13 in this binary form. And that's the basic reason that why we start from left to right instead of starting from right to left. So if you try to compare this back, it won't be the altogether 28. So which means that starting from right to left fails. So let's consider another example, and let's try to convert it back. Let's say 52. So if we try to okay, so first write down the powers of 2. Power 0, 2 power 1, 2 power 2, 3, 4, 5, 6, and then 7. 2 power 0 is 1, 2 power 2 is 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 3 is 8, 2 power 4 is 16, 2 power 5 is 32, then 64, and finally 2 power 7 is 128. I am repeating these numbers over and over again so that you can remember these numbers much quicker. And now let's consider the example, which is 52. So if we compare this 52 with the first number starting from left to right, if you compare 52 from 128, 128 is of course greater than 52. So which means that we cannot put 1 here, because we do not want this 128 to be added in the final answer while converting from binary to denary. and that's why it's 0 here. In the next one, if you compare 52 with 64, 64 is of course greater than 52, which means that we do not want this number to be added in the final answer, hence we will place 0 here. And next, if you compare 52 with 32, and as you guys can see that 32 is less than 52, which means we need to add this number in our final answer. So we will place 32, and if we subtract 52 by 32, it becomes 20. The next step, we will compare this 20 and not this 52. It's must. We will compare this 20 with the next number, not 52. You need to make sure you need to be very careful with it. So if we compare 20 with 16, of course 20 is greater than 16, which means we will place 1 here. And then if we subtract 16 from 20, it becomes 4. And then we compare this 4 and not this 20 or this 52. We compare this 4 from this 8. So if we compare this 4 from this 8, so 4 is of course less than 8, so we cannot place 1 here because we do not want this 8 to be added in our final answer, because if we will add this 8, it will add up with this one and with this one, and the final answer will become greater than 52. That's why we cannot put 1 here. We need to put 0 instead. So if, next, if we compare 4 with 4, it's of course equal to, and as I said that the number can be equal to, not necessarily greater. So since it's equal to, we will place 1 here. So if we subtract this 4 from this 4, it becomes 0, which means that we do not need any more 1s. So the next we will place 0 and 0. And if we try to add these up all together, like all those 1s, the corresponding numbers with them, it will eventually become 52. You can even see it. If we add this 32 with this one, 16 with this one, and 4 with this one, it will eventually becomes 32. Oh sorry, 52. Which means that this method is legit, and we can we need to move from left to right instead of moving from right to left. Thank you very much guys for watching this video. If you love this video, please make sure to like, subscribe, comment and share so more and more people can benefit from this video, and I will see you in the next one.